Billions of years ago, waves rolled across this horizon, rivers carved valleys through distant mountains, and rain may have fallen from a blue sky, and then everything died, not in a single explosion, not in a cosmic catastrophe, just a slow, silent, planetary death. Today we call this world Mars, a frozen desert of dust, rock, and memory. For centuries we imagined alien cities and hidden canals. But what NASA actually uncovered is far more disturbing. Because Mars isn't frightening because it's alien. Mars is frightening because it's familiar. Tonight, we're counting down 10 discoveries that turned Mars from a fascinating neighbor into one of the most unsettling worlds in the solar system. And the terrifying question isn't what happened to Mars, it's whether it could happen here. Alright, let's get into it. Number 10. Ancient river valleys. In the 1970s, NASA's Viking orbiters began sending back images that changed everything. Scientists expected craters, volcanoes, a world that had always been dry. Instead, they found something hauntingly familiar. River valleys. Thousands of them. Some stretched for hundreds of miles. Others branched into complex networks that looked remarkably like river systems on Earth. These weren't random cracks. They followed the flow and erosion patterns geologists recognized instantly. And for water to carve channels like these, it had to flow for a very long time. Not days, potentially millions of years. That shattered the old image of Mars as a world that had always been frozen. Because rivers aren't just rivers. They require a water cycle, a stable climate, and temperatures that stay above freezing. Modern Mars can do none of that. Its atmosphere is now so thin that exposed water freezes or boils away almost instantly. Yet the valleys remain, like fossils embedded in stone, like fingerprints left by a vanished world. Imagine wandering into a desert and finding the dried bed of the Mississippi, then another, and another, thousands of them crossing an entire continent. You wouldn't conclude water merely passed through. You'd conclude water once ruled here. That is exactly what happened on Mars. Later missions only sharpened the picture, revealing branching drainage networks, ancient shorelines, and valleys that took thousands or millions of years to form. The evidence didn't fade under scrutiny. It multiplied. And if Mars once had flowing water, it once held one of the most important ingredients for life. When we look at those valleys, we aren't seeing geology. We're seeing the remains of a world that lost its chance. And the rivers are only the beginning. Number 9. The dried-up lakes. Finding rivers is unsettling. Finding lakes is worse. Rivers can exist briefly. Lakes imply permanence. In 2004, NASA's Opportunity rover landed inside Eagle Crater and examined the local rocks. What it found became some of the strongest evidence, yet that liquid water once covered large regions of Mars. The rocks held sedimentary structures, layered deposits, and minerals that only form in the presence of water. The signatures were unmistakable. Later missions expanded the picture. Orbiters mapped ancient lake basins, and the Curiosity rover explored Gale Crater, a site scientists now believe once held a massive lake system that may have lasted for millions of years. Think about what that means. Not puddles, not temporary floods, entire bodies of standing water, lasting long enough to accumulate sediment layer by layer. On Earth, lakes are archives. They preserve chemistry, environmental history, and habitats where microorganisms thrive. Mars appears to have written the same pages, then stopped. The lake beds remained. The water vanished. Imagine discovering the ruins of a city beneath the ocean floor. Streets, foundations, walls, everything suggesting a thriving civilization. Now imagine there are no survivors, no records, no explanation. Only ruins. Each layer of sediment is a frozen moment, and stacked together they hint at conditions that stayed gentle and stable for far longer than any passing flood. That kind of stability is exactly what fragile life needs to take hold. That is what these lake beds feel like to planetary scientists. The discovery transformed the question from fantasy into science. Researchers stopped asking whether Mars had ever been habitable and started asking how habitable it might have been. Because a world that was never alive is one thing. A world that might once have supported life is something else entirely. Number 8. The methane mystery. Now we move from ancient Mars to modern Mars, and this is where things turn truly strange. Methane shouldn't be there, yet sometimes it is. In 2003, Earth-based observations hinted at methane in the Martian atmosphere. Later, NASA's Curiosity rover detected methane spikes inside Gale Crater, while other missions sometimes failed to find any at all. Methane appears, disappears, rises, and falls, and no one fully understands why. On Earth, methane can form through geology, but a huge fraction of it comes from biology. Microorganisms generate enormous amounts of it. That single fact instantly captured public attention. Could Martian methane be a sign of life? Scientists stay extremely cautious. There are non-biological explanations, reactions between rock and water, subsurface geological activity, or ancient reservoirs leaking gas periodically. All remain under investigation, but the mystery refuses to disappear. Newer orbiters designed to sniff out even faint traces have sometimes found almost nothing, deepening the confusion rather than resolving it. If the methane is real, something must be both producing it and destroying it far faster than our current models allow. The strangest part isn't the presence of methane, it's the behavior. Models struggle to explain how it seems to fluctuate so quickly, appearing and vanishing on timescales that are hard to reconcile with what we expect. Imagine entering an abandoned house. No lights, no sounds. No sign anyone lives there. Then, every few nights, smoke rises from the chimney. Not enough to prove someone's inside, but enough to make you wonder. That's the methane problem. No one claims it proves life. The evidence doesn't support that. But it can't be dismissed either. And that uncertainty is what makes it disturbing. The terrifying part isn't what we know, it's what the data refuses to rule out. Number 7. Water ice beneath the surface. For generations, Mars was imagined as a bone-dry world. Then NASA discovered something extraordinary. The water never completely left. A great deal of it is still there, hidden beneath the dust, the rocks, and the frozen surface. Data from orbiters, landers, and radar revealed enormous deposits of water ice across Mars. Some lie near the poles. Others sit surprisingly close to the surface in mid-latitude regions. The quantities are staggering. If melted, some deposits would represent vast amounts of water, not enough to restore ancient oceans, but enough to reshape our understanding of the planet. The discovery thrilled mission planners, because water means drinking water, oxygen, and rocket fuel for future explorers. But there's a darker side. Every deposit of buried ice is a reminder that Mars once held far more water than it does today, and that habitability can be temporary. Imagine entering an abandoned cathedral. The congregation is gone, the candles are out, the roof has collapsed. Yet deep inside, you find a sealed room still holding relics from centuries ago. Those relics don't mean the cathedral is alive, they mean it once was. That is what Martian ice represents, a surviving fragment of a lost era. Scientists believe ancient Mars may have had rivers, lakes, glaciers, and perhaps oceans. Over billions of years, most of that water escaped into space, locked into minerals, or froze underground. What remains are scattered, frozen memories of a wetter planet, proof that even entire worlds can become ghosts of their former selves. And it raises an uncomfortable question. What exactly killed Mars, and could it happen again? Number 6. The poison hidden in Martian soil. If humanity ever builds a city on Mars, the greatest danger may not come from space. It may already be under our feet. In 2008, NASA's Phoenix lander made a discovery that complicated every dream of turning Mars into a second Earth. Mixed into the Martian soil were chemicals called perchlorates. That might not sound alarming, but perchlorates are highly reactive compounds. On Earth, they're used in rocket propellants and industrial processes, and in large quantities they can interfere with biological functions and harm human health. The finding forced scientists to rethink what Martian dirt actually is. For decades, people pictured Mars as a giant desert, harsh and dry, but fundamentally like deserts on Earth. The reality is stranger. Martian soil isn't simply dirt, it's chemically hostile dirt. It gets worse. Perchlorates interact with radiation, and Mars lacks the magnetic shield that protects Earth. As radiation bombards the surface, chemical reactions can create compounds even more damaging to living cells. In other words, the ground itself may help make the environment toxic. Imagine surviving a shipwreck and washing up on an island. You find frozen water, sunlight, raw materials, everything looks survivable. Then you discover the soil is laced with poison. Every crop becomes a struggle, every handful of dirt becomes a hazard, and the poison isn't confined to one spot. Perchlorates appear to be spread widely across the planet, woven into the dust that coats nearly every surface and blows into every crack. Any future colony would have to filter it from the air, scrub it from equipment, and keep it out of the food supply. That's the reality NASA uncovered. Perchlorate doesn't make Mars impossible. Technology may one day neutralize them. But the message is deeper. Mars isn't merely empty. In many ways, it actively resists life. Number 5. Global dust storms. Earth has hurricanes, blizzards, and tornadoes. Mars has something far worse. A storm capable of swallowing an entire planet. Every few years, local Martian dust storms begin to merge. Small storms become regional events, and under the right conditions, chaos spreads across nearly the whole world. The result is a global dust storm, a planetary weather system unlike anything on Earth. In 2018, one such storm grew so large it completely engulfed Mars. Spacecraft in orbit watched the surface disappear beneath a veil of dust, as features visible for decades vanished from sight. And on the ground, NASA's Opportunity rover faced its final battle. Opportunity had operated for nearly 15 years, vastly exceeding its planned mission. It survived brutal winters and crossed alien landscapes. Then the storm arrived. Dust blocked sunlight from its solar panels. Power dropped. Temperatures fell. Communication ceased. The last message it sent became famous. "My battery is low and it's getting dark." Then silence. Forever. The science is fascinating. Mars's atmosphere is thin, but its dust is incredibly fine. Once lifted, particles stay suspended for a long time, and as sunlight heats regions unevenly, powerful circulation feeds the growing storm. But the emotional weight is something else. Imagine a planet where the weather can erase the horizon itself, where daylight fades, not because night arrives, but because the sky becomes a wall of dust. No shelter, no warning, no escape. And these storms aren't rare accidents. They're natural. Mars doesn't consider them disasters. Mars considers them weather. And that hints at a much larger mystery. Because the real killer of Mars was something far more fundamental. Number 4. How Mars lost its atmosphere. This may be the most important discovery NASA has ever made about Mars. Because without it, none of the others make sense. Ancient rivers, ancient lakes, buried ice, all point to a world that was once warmer and wetter. So what happened? Where did everything go? The answer is written in the sky, or rather, in the sky that no longer exists. Today, Mars has an atmosphere less than 1% as dense as Earth's. It's so thin that liquid water can't stay stable on the surface. Temperatures swing wildly, and radiation reaches the ground almost unopposed. But evidence suggests Mars once had a far thicker atmosphere, a blanket of gas capable of trapping heat and supporting liquid water. Then the planet lost it. NASA's MAVEN mission, launched in 2013, was built to investigate exactly this. What it found painted a chilling picture. Billions of years ago, Mars likely had a global magnetic field like Earth's, a shield deflecting charged particles from the Sun. Then the Martian dynamo shut down. The shield weakened. The atmosphere became exposed, and the solar wind began stripping it away, not in a single event, but in a slow, relentless process lasting hundreds of millions of years. Atom by atom, breath by breath. The Sun didn't explode. It didn't attack Mars. It simply kept being the Sun, and Mars gradually lost the ability to defend itself. There was no villain, no asteroid, just physics, cold, indifferent, unstoppable. The atmosphere thinned, temperatures dropped, surface water disappeared, habitability collapsed, and the implication reaches far beyond Mars. Habitability is not permanent. It is not a birthright. It is a fragile balance that can fail, and Mars may be the clearest example in the solar system of what happens when that balance breaks. Number 3. Signs that Mars was once habitable. There's a crucial difference between finding life and finding a place where life could exist. NASA has not discovered living organisms on Mars. No rover has photographed a microbe. No spacecraft has confirmed Martian biology. But over 2 decades, mission after mission has revealed something almost as provocative. Ancient Mars appears to have had many of the ingredients life requires. Liquid water, energy sources, chemical building blocks, stable environments lasting potentially millions of years. One by one, the pieces fell into place. The Curiosity rover found evidence of ancient freshwater inside Gale Crater, along with minerals that formed in conditions far less acidic and hostile than expected. Some ancient Martian environments appear to have been surprisingly mild, not Earth-like, but potentially habitable. That word changed everything. Habitable. Because once a world crosses that threshold, even in theory, a profound question emerges. If the conditions existed, Did life ever take advantage of them? No one knows. The most honest answer is also the most frustrating. We don't know. And the possibility refuses to fade. Imagine finding an abandoned house deep in a forest. Inside are water lines, wiring, furniture, a fireplace, everything needed to live. But no occupants, no photographs, no explanation. Would you conclude nobody ever lived there? Or would you wonder what happened to them? Mars creates that same effect. Not proof, possibility. And possibility is sometimes more unsettling than certainty, because certainty ends the mystery while possibility keeps it alive. If life never appeared in a world with water, chemistry, energy, and time, how rare must life be? And if it did appear, what happened to it? Did it die out as the planet frees, or is it still clinging on somewhere deep underground, hidden from every camera we have ever sent? Either answer is unsettling in its own way. Number 2. The rock samples Perseverance is collecting. Imagine spending billions of dollars to collect a handful of rocks. It sounds absurd until you realize those rocks may hold the most important clues in the history of Mars. In February 2021, NASA's Perseverance rover landed inside Jezero crater, one of the most scientifically valuable sites ever explored on another world. Scientists chose it for a reason. Billions of years ago, Jezero wasn't a crater. It was a lake, fed by rivers flowing into a delta system still visible from orbit today. And on Earth, river deltas are extraordinary archives. They trap sediment, preserve organic material, and record environmental history layer by layer. If ancient Martian life ever existed, a place like Jezero might preserve its traces better than almost anywhere else. Since landing, Perseverance has been drilling into rock, sealing carefully chosen samples, and storing them for a future mission that may one day carry them back to Earth. Think about that. Humanity is collecting pieces of another world to transport across millions of miles of space, so they can be studied in labs far more powerful than any rover. But the most disturbing part isn't what the samples are, it's what they represent. Every core is a message from a vanished planet, a fragment of an environment that no longer exists. Scientists are hunting for biosignatures, chemical patterns, and mineral structures hinting at ancient life. Nothing has been confirmed, but imagine opening one of these samples decades from now and finding undeniable proof that microbes once lived on Mars. Even that would change history, because it would mean life emerged independently on two neighboring worlds. Earth would no longer be unique. And if life emerged on Mars and then vanished, it would reveal something chilling. Life may not be rare. Survival might be. Number 1. Mars as a reflection of Earth's possible future. When most people look at Mars, they see another planet. Scientists increasingly see something else, a warning. Everything in this countdown points to the same conclusion. Ancient rivers, ancient lakes, buried water, a thicker atmosphere, potentially habitable environments. Together they tell a story of transformation, loss, and planetary mortality. Today, Earth feels permanent. The oceans, the atmosphere, the climate, civilization itself, all seem stable and established. But Mars reminds us that none of those assumptions are guaranteed. 4 billion years ago, the differences between Earth and Mars may have been far smaller than they are now. Both had water, both had atmospheres, both formed in the same young solar system, yet one stayed habitable and the other became a desert. That is the nightmare hidden inside the Martian story, not because Earth is destined to become Mars. Current science doesn't support such a simple conclusion. Earth is larger, geologically active, shielded by a strong magnetic field and plate tectonics. The planets are different. But the lesson stands. Habitability is fragile. Conditions that appear stable can disappear. And it can happen without drama, without intention, without meaning. Just physics. The same physics that operates throughout the universe. Imagine walking through an abandoned city. The buildings remain. The streets remain. But the people are gone. And the silence feels heavier. Because the evidence of the past is everywhere. That is Mars, a planetary ruin covered in clues pointing to a history that no longer exists. It hangs in the night sky like a fossilized future, not a prophecy, not a prediction, a reminder that worlds can die and that the universe offers no guarantees. We began with river valleys carved by flowing water. We found ancient lakes, vanishing methane, buried ice, poisoned soil, planet-swallowing storms, and an atmosphere that slowly bled into space. Separately, they seem unrelated. Together, they tell one story, the story of a world that changed and lost almost everything. Mars is terrifying because it doesn't look alien, it looks familiar. Familiar enough to make us wonder how fragile our own world really is. The universe didn't destroy Mars in a single moment. It simply let physics take its course, and billions of years later, the evidence still lies scattered across the surface, like the ruins of a forgotten age. Perhaps Mars never hosted life. Perhaps it did. We don't know. And that uncertainty may be the most disturbing discovery of all. Somewhere out there, a dead planet is still whispering one question. Could it happen here? Sleep well. I'll be sharing more videos like this soon, so subscribe to stay tuned.